Hello everyone, welcome to my channel. In this video, I will solve permutation 2 problem. Now, here our problem is given a collection of names that might contain duplicates. Return all the possible unique permutation in any order. So, first I write here algorithm. After that, I will write down the code. So, here in algorithm, first sort the input array names. Sort the input array names. This step will help us handle duplicate efficiency. And next is we need to initialize an empty list result to store unique permutation. Result empty list result to store unique permutation. Now 3 is create a helper function. Now we need to declare a helper function backtrack. The name of this helper function is backtrack that takes three parameters. One is path, second is used, and third is count. So we need to create a helper function backtrack. In this backtrack function, we need to take three parameters. First, we need to take three parameters. First parameter is path, second is used, and third is count. First, now what is path? A path is a list of store that current permutation. Now it is used, a boolean array to keep track of which element have been used in current permutation. Means a boolean array to keep track of which element have been used in current permutation. Last is count. What is count? An integer array to keep track of the count of each element in the current permutation. Now we need to check if the length of this path is equal to the length of these nums. So we need to check if the length of path is length of nums. If it is, add a copy of path to result and return the result. So next is we need to now iterate over the indices of nums. Iterate over the indices of nums from 0 to the length of num. 0 to length of num. If now iterate over the indices of nums from 0 to the length of array, length of nums. Now here first is if used I is true or I is greater than 0 and nums of I is equal to and nums of I is equal to nums of I minus 1 and and used I minus 1 is false, and use I minus 1 is false. Continue the next iteration. Continue the next iteration. If used of I again repeat these things. If used I is true, or I is greater than 0, and nums of I is equal to uh, nums of I minus 1, and I minus 1 is false. Used I minus 1 is false, so continue the next iteration. This condition ensures that we skip duplicate in the current level of the backtracking tree. Now we need to increment amount of nums I by 1. Now next is append nums of I to path, and set used of I is true. Next is we need to set used of I is true, and recursively call backtrack. Again we need to call the backtrack with the update path used and count with the updated path, comma, used and count. Decrement count of we need to next we need to decrement count of nums of I by 1. Next we need to remove the last element from the path. Remove last element. Set. Now we need to set used of I is false. So next is we need to call the backtrack function with the empty path. Call the backtrack function with an empty path, a boolean array used of size equal to the length of nums, and an integer array count of size 21, and an integer array count of size 21. Return the result list. Now at last return the result list. So first we need to sort the input array names. Second, we need to initialize a empty list result to store unique permutation. Third is create a helper function backtrack that takes three parameters. First is path, second is used, and third is count. After that, check if the length of the path is equal to the length of nums. If it is, add a copy of path to the result and return. Now, next is iterate over the indices of nums from 0 to length of nums. If used of I is true or I is greater than 0 and nums of I is equal to nums of I minus 1 and used of I minus 1 is false, continue the next iteration. Next is increment count nums of I by 1. Append, after that append nums of I to the path. Nums of I to the path, and after that set used of I is true. Backtrack. Next is recursively call backtrack with updated path used and count. Decrement count nums of I by 1. Remove the last element from the path. Set used of I is false. And after that, call the backtrack function with a empty path, a boolean array used of size equal to the length of num, and an integer of array count of size 21. At last, return the result. So first create here one function permutation and take nums as a parameter. After that, sort the nums. After sorting the nums, then initialize an empty list result. Now we need to create a helper function backtrack. So def backtrack, and in this function we need to take three parameters. First is path, second is used, and third is count. Now check the condition. If length of path is equal to length of nums, then result dot append path clone and return. For after that, for I is length of I in range of I in range of length of nums for I in range of length of nums, then take again condition. If used of I is true, used of I or I is greater than 0 and nums of I equal to nums of I minus 1 and not used I minus 1. So we need to continue our next iteration, and we need to increment the count nums of I 1 path dot append nums of I, and used of I equal to true. Now again we need to call the backtrack path used and count. After calling the backtrack, we need to decrement the count of nums I equal to minus equal to 1, and pop the last element of the path. Now path dot pop used of I equal to false. Backtrack here, first value is empty, path is empty, and here write false into length of nums comma 0 into 21. So at last return the result. Here our problem is nums is 1 1 2, and print the permutation of nums. Save it and run this program. Python okay. Here it show one error, and oh sorry, here is not array of 21, only 21. So save it and run this program again. You see our program is now working. Here 112, 121, and 211. So I think it is clear to you all. That's all for today. See you in the next video. Please leave a like and subscribe my channel. Okay, thank you.